Okay, welcome back to a new video. In this video, we're going to talk about kind of more engine concepts. So typically in vLLM, SGLang, you have your model, but then you have this like engine that wraps around the actual model code, and this is where a lot of the efficiencies come about. Okay, so there's three concepts we want to cover today. So the first is called chunked prefill, and the basic idea is that in the last lecture we said how prefill, we take the entire prompt, run it through the model. But there are times where you might not want to run the full prompt through the model. And instead, you might want to run just part of the prompt. So maybe you run like the first 3 tokens. In practice, you wouldn't want to do this, but like let's say you had 10,000 tokens, maybe you run the first 3,000 tokens. So this would be an example of the first 3,000 tokens. And the basic idea is you do your first 3,000 tokens, you do a forward pass, and then you do your second 3,000 tokens. And the key is that after you did the first 3,000 tokens, you've populated the KV cache such that when you do the second 3,000 tokens, it's actually semantically the same because you already have memoized that first 3,000 computation. Now you might be wondering, why would you want to do this? And there's 2 reasons. The first is that if your prompt is sufficiently long, you'll run out of memory when you try to do the forward pass. And so by chunking, you can kind of reduce the peak memory usage. But the second reason is because, as we'll see, if you chunk, the chunk will take less time than the full prompt. And so when you start batching things together and you start considering latency, it's sometimes useful to do these prefills in chunks. Okay, the second concept I want to talk about is ragged batching. So if we think about these LLM systems, they have a series of prefill and decode requests coming in. And especially for prefill, the length of the prompts vary. And so that's a little awkward. Basically, you either have to pad or you have to do this. And so the basic idea here is that you can basically concatenate all of your prompts together. And in the same way that we do causal masking and attention and vanilla attention, you can kind of do this like document or prompt masking, if you will, where you have this huge matrix, but you can basically mask out large portions of it so that your prompt only attends to the tokens in your prompt and their prompt only attends to tokens in their prompt. And then the last concept that I want to cover today is continuous batching. And the basic idea here is that you have a request queue where requests are coming in to do either prefill or decode, and you basically have an engine that is constantly running batches through the model. And after every single batch, we will see if any of the requests have finished in the batch. And if so, we kind of pop that out of the batch and then we take a new request and put it in. So here you can see an example. So imagine we have these 3 prompts: who ate the pie, I am sure this project, and then the largest animal. So the first time you just have who ate the pie forward pass, you get a question mark out. Then the second time around, you do something interesting. So you have the prefill from the first, right? You've taken this question mark token, appended it, and then you also have I am sure this project. But notice that this is a chunked prefill. So we're only prefilling these first 4 tokens. And after running this batch through the engine, we predict end of sentence. And so we know that this ends. And so in the next forward pass, we can finish this chunk prefill. We can do this project prefill, as well as a single decode. And then we can start the next prefill of beginning of sentence, and then largest animal, whatever. And you can see like these engines, they're basically they're continuously batching these requests. And then just to like loop back to like why you want chunked prefill, one reason is because imagine if you did have enough memory and this was a really, really long prompt, then in some sense, you're going to sacrifice the latency of predicting this token because this compute is going to be so long. And so by chunking it, you basically can like limit the latency budget for your prefills. And so you can do this continuous batching. So this in many ways is kind of the core techniques for single node LLM inference. And it's quite coherent. But in future lectures, we're going to talk about problems with this and why you might want to do something slightly different called disaggregated prefill decode. But hopefully this was intuitive, and I will see you in the next one.